please. Um, Hello?
Yes, I can hear you.
Yes. Good morning, all. I am Dr. T. Babu, head of the Department of Instrumentation and Control Engineering of St. Joseph College of Engineering. I proudly organize this kind of webinar. He is today's presenter is a well-known person from our department. Now he is presently associated with German, one of the famous software introduced by them is the MP3 and the MP4, what we are using today And about our college, our college is recently accredited with a A+ grade with the highest score, that is 3.46 out of 4 scale. And now the NIRF rank is obtained for the latest rank is 160 out of 1071 applied institutions all over India. Our college is started in the year 1994, so around 26 year 26 year is going on. Now at present we are having 10 departments, 10 UG departments, and 6 PG departments. And about our department, that is Instrumentation and Control Engineering, it is started when the college is established, that is in the year 1994. And from 2003 onwards, it is accredited. I can proudly say that the major strength of our department is more than 50% of the faculty members are holding doctorate degrees, and they are producing very good research report and everything. And I can proudly say about our laboratory. It has a very good and well equipped laboratory with recent equipments. With this small introduction about our department and college, I am asking Mr. Adhithyan Ramadoss to present this wonderful webinar. After following Adhithyan, one more person from the same batch, that is Sathyanarayanan, I will also present with another one topic. Actually, he is associated with the Chennai, and he is also having same kind of a vast experience, and he is holding a senior instrumentation and control engineering in a TechnipFMC company. Both of them will present today's topics. Audience, please put your call voice on mic on hold or mute conditions. And if you have any doubt, you please put it in a chat box. At the end of the seminar, the presenter will be answer to your questions. Now, please, Adhithyan, please start your presentation.
Thank you, sir. So I would share my screen. Just let me know if you can see my screen. Yes. So can you guys see the screen?
Yeah.
Okay. Nice. Give me 1 minute so we can begin it. Okay. So since I see most of the participants are here, so I see like about 30 people now. Wait 1 minute, guys. Satya?
Yeah. Yes,
just manage the people who are in the waiting room. So just let them in and then control all those.
Yeah,
so,
sure.
Because I would keep getting a pop-up otherwise. Yeah.
Yeah, sure. I will do.
Okay. Yeah. Fine. So good morning to you all. So I think it's around 11 a.m. in India now. So hope you all have a nice morning. So to start with, okay, there is some sort of a line on this slide, but yeah, sure. Okay. So, okay, before we begin, I just want to make this session an interactive one. So I would be really happy if you guys could actively participate in something. So we just prepared some polls and things. So it would be really nice if I could also get an answer from you, because this is designed to be an interactive session. So I would like to get your feedbacks and things. So also, if you have questions, you can type it in the chat, or I can also take it at the end of my session, or like the end of both our sessions together, so where we have a larger question and answer session. So if you have questions, raise your hands, and also I would be happy like if you could put it in chat. Yes. So first thing would be, so I already asked you how you're feeling, so I couldn't get an answer for that because you're already mute. So I would ask you to go to this website. So this is called menti.com. So you have your smartphones or anything, just go to this page, and then it will ask you for a code to enter. So use the code here, the number shown here, 227156. So just go there. So I would be glad to get your how you're feeling today already. So maybe we'll spend like around a minute on this. I have a few more questions. So yeah, as I said, I would like to keep it interactive. Well, that's a good start.
What happened, Adityan?
Yes, sir. So we are waiting for the poll. So I just want to keep it interactive. So there is this website. So this website shown here. So you can log into it and use this code, and then you can answer this poll. And as I said, I would be really glad if you could answer it. So
Yeah. That is why I asked the people to put all the mics on hold, and whatever the queries they have, they can put it in chat box.
yeah, yes, sure.
Yeah.
So
All participants, please put your mic on hold, and you please post your queries in the chat box, so that we can continue the session in a fruitful manner. Thank you. You please continue the Adityan. You
yes, sir.
please
Yes, sir.
continue.
No. I'm just waiting for some more answers to collect. So it's not a problem. It's just a part of the seminar. So it's okay.
Okay.
So guys, maybe like 30 more seconds. Okay, so I see that the answers have stopped coming, so fine. So I see that most of you who answered the poll are quite cheerful in the morning, and you're all waiting to learn new things. So yes, that's a good start already for me. And it's also sad that the corona situation still persists in India, and I understand why you guys would be bored there. So to continue with the session. So I would give a very top level overview of the machine learning developments from the start of it. So I would not go very in detail about things or the algorithms or the models which you're talking today. But if you have questions, you can raise them in the end. So I would be glad to still discuss them with you. So saying that, so here you can see that I have listed a table which says how the machine learning technology has raised over the years. So you can see that, so machine learning it's all fancy now, it's all hyped up, you see it like everywhere, it's machine learning is the hot topic. But machine learning as a field of research is not something new. It has been there from the 1950s, so it's already 70-year-old technology. So we'll just quickly look at how things went. So 1950s, as I said, was the start of the machine learning research build up. And this was from IBM, the erstwhile very popular computer company. So this was the key developer of a lot of computer technologies in the 50s and say even until the 80s, until larger companies say like Apple or something came up, and then they became the leaders of their field. So in 50s, there was this guy who developed a program to play checkers against itself. So I'm not sure how many of you have played checkers, but this is a relatively simple game. So he developed a machine which could play against itself, learn, and then to itself. So this guy, he claimed he didn't know how to play checker very well, but his machine was even at that time able to beat him in multiple games. So, and this was also in 1957, Frank Rosenblatt also invented the Rosenblatt perceptron. So this was like the forefather of the artificial neuron, which we all use in all our deep neural networks now. But there are some deficiencies in that, and we won't see about it. But I would be very happy if you guys could take your time and then go through this later in your own time. Right. And in 60s came k-nearest neighbor algorithms, and there was also development in the Rosenblatt perceptron where they had multi-layers added to it, and Bayesian methods, which are very popular in probabilistic statistical methods. So they were also started being implemented in the machine learning field. I think one of the hosts is drawing something over the screen. I would be happy if you don't do it, please. Okay. And but k-nearest neighbor and things are not really like deep neural networks or neural network by itself. So these are all machine learning techniques. And in the 70s, there was a popular book which said Rosenblatt has its own, as I said, its own deficiencies, where they said that it's not non-linear, so you cannot achieve a lot of things with this. So this book was very popular, but that book single-handedly managed to bring down the whole research interest in machine learning, field of machine learning. So 70s, there were not a lot of research in machine learning, but in the 80s, they rediscovered backpropagation. So this is one technique. If you're already using machine learning, you probably are very, very aware of what's happening. Guys, could you see my screen? I think my screen went out for a moment.
Yeah, it is in a hold. It is in still we are seeing the rise of machine learning.
Yes. So I think it went on hold. Okay, so then in the 80s came like all your backpropagation, and then they had some serious research. So all the recurrent neural network or the reinforcement learning techniques, at least the Q-learning part of it, was already developed in the 80s. And then came 90s, so where we went for support vector machines or random forest. So these are all unsupervised learning methods, or SVM is not really unsupervised, but yes, it's also supervised. But these are all not deep neural networks or neural networks by itself. So these are all subsets of machine learning. So, but they have very, very good results which are still being used. So I would like to put it out there. And then 90s was a big year for the community, because if you remember in 1996, this was the year when the machine called Deep Blue from IBM again defeated Garry Kasparov, the then chess champion of the world. So this was the time where they proved that machines could actually become better than what humans are capable of. So this was another important milestone for the field of machine learning. Then in the 2000s came improvements over all the existing techniques. So unsupervised learning methods became more interesting. So all your clustering algorithms or the k-means or whatever, so they become a little more interesting. And also the interest in the field of language processing became very important. So if you remember, I'm not sure if so many of you were already born then, but yes, in 2001, there was this attack on the Twin Towers in the US. So then the US government then decided to invest a lot of money in researching the Arabic language. So building machines which could decode Arabic language. So they could, spy on the communication over there, so they could understand what's happening. So instead of training many people or hiring many people who spoke Arabic well, they started developing machines which could do it. So here you're already seeing some real life incident directly impacting the research interest. And then in 2010, so especially in 2012, there was this. So I'm not sure if you know of this ImageNet challenge. So this is a challenge where you have your model or your algorithm has to classify different categories of pictures given there. So there are multiple categories. So I think around 1,000 categories at least. So this was the first time when a machine learning model, a deep learning model, significantly had a better performance than the other models. So there were already machine learning models by say 2006. But this AlexNet was the first time when they were in the top 5, and they had like 10% better performance than everyone else there. So this was what is like the spark point of deep learning research interest. So as I said again, so these are like how you would picture the field of artificial intelligence or machine learning, because these words are pretty used commonly now, and they are all interchangeably used. But if you really look at the scientific community's approach to them, they're not replaceable, or you cannot use one word for the other. But so artificial intelligence on the whole would be the larger subset, and then machine learning would be a smaller part of that, where deep learning is just a very small part of that. So things like SVM and all the k-means and the other things would still fall in machine learning, but they are not deep learning. And again, you have this huge race of big data and the techniques of data sciences now. So they overlap with all these techniques, but they are also separate on their own. So they have their own fundamentals. They can stand on their own, but there are again overlaps through this. So So today we would be primarily talking about deep learning. And also note that even if I say machine learning or artificial intelligence, I actually mean deep learning, because today's talk is only on a very high level introduction to deep learning. So having said that, why is deep learning so important now? So if you remember, deep learning has not been around for the last 50 years or something. Nobody was talking like deep learning would be the next big thing, because deep learning has been there for the last 70 years. But the spark or the huge media hype, the buzz around it has been only existing for the last 5-ish years. So why that is because deep learning has now matured into a field to an extent. So it's not big already. It started maturing to an extent where it can show real life impacts, and it is now one of the fastest growing fields. And the other reason is it has very strong research potential now. And again, startup potential is also one more reason why people are exploring it. So if you know Uber or say Zomato or anything, they all started as startups using deep learning. So now you see how big they have become. So this is one more reason why so many people are investing their time and energy into doing this. But what really led to all this is because now you have very cheap compute power. So all your GPUs cost have reduced. So now you can calculate billions of tensors per second. So your multiplication techniques have improved in your computers. So your computers are now very fast. So they can do many things much faster. And also now the internet is another big reason why this is famous. So also my talk might not be the first machine learning talk you're listening. That I'm pretty sure you would have seen. Machine learning has become one of the most sought out topic, and the internet is catering to all your interests. So if you go type machine learning into Google, you will have like millions of resources for you to go through and learn things. So the community is now so open, because usually in the other communities, so in the other research communities, they don't actually publish the papers. So they publish the papers, but only the results of it, and just a very vague description of how the technology behind it works. So but this community is very open. So they actually give you their codes. So they put it somewhere in the internet, so you can take it, use it, modify it. So you are usually provided with all the licenses. So this is one of the reasons machine learning is also very interesting for like beginners who have no idea about things. So having said that, I would like to also have one more question quickly. So where do you guys stand in the field of machine learning? So you know what machine learning is, you've already seen it, or you have no clue about it. So what is your level of standing in machine learning? So again, I use the help of another Mentimeter poll. So go to Mentimeter and then use this code 346613. I would be happy to get some answers, because then I could decide if I can just go a bit deeper or just talk. If so many people say that you're beginners, then I would talk in a very top level stage. But if you're already very aware of what's machine learning, then I could actually also discuss deeper. So let's take about a minute to do this. So guys, please answer to these questions. So this is for me to know how my audience wants things. So because the talk is for you guys, so would be happy to know how you feel about things. Maybe 10 more seconds and then we move on. Okay, so seems like at least half of the people who voted, they are already aware of the topic. So as I said, you probably had a lot of seminars or you attended classes on it. You probably also tried a few things. And one more thing I would also want to know is, since this would also be interesting for Satya, is that what you really want from this talk. So would you want to just know so this would also help us to determine the amount of time we spend on each topic. So do quickly answer this. So here you can choose multiple options. So you can even choose like 3 or 4 of them, whatever suits you. So maybe 10 more seconds and then we'll close this one too. Okay, so at least from the current standings of the poll, I see the oil and gas industry's scope is of a bigger interest for you guys. So Satya, please do take a note of this. So your talk is the most sought after one here today.
Yes.
And
Yeah,
of
sure.
course, I also thank the people who said they are here just for the certificate. So thank you for your frankness. So it's also happy to see people are willing to be open about what they really need from specific talks. So go ahead, good luck for that too. So let's go back to the talk. So I would make it a bit faster because I see from the I understand from the poll that most of you are, at least who answered, most of you are looking for the oil and gas part of it. So I would keep it as fast as possible then. So we have been talking about deep learning, doing that and this. So probably most of you know how deep learning has impacted our daily lives, but here are some examples. So some of you already probably have all these Google Home devices or Amazon Alexa or whatever new fancy voice assistant sitting on your tables in your living room or anywhere, or most of you do have a smartphone. So if you have an Apple, it's Siri, or if you have Google, it's an OK Google voice assistant. So all these are something which have become part and parcel of our life. So pretty much we use them every day. So I think at least some of my friends use it, like they have 2 of them in their living rooms and things like that. So it's a very common thing to be used now. And one more thing is most of us use Google Maps. So it's the idea of asking someone on the street on how to reach a place has been reducing drastically. So we all have smartphones. We just open the Google Maps, type the direction, destination, and it shows us direction. Even here, if you see that it shows multiple directions, and it actually picks one specific direction for you. This is also by analyzing multiple data things. So it analyzes traffic or other multiple distance or how elevated and how you want to travel and all that. And these are all machine learning techniques driving them. And again, so Google, which I think everybody uses, there is nobody who doesn't use Google. So Google is also like now driven by machine learning or deep learning in specific behind it. And again, Netflix. So probably in the quarantine, most of you have been watching videos or like spending your times a little with the social media part of it. So you can see Netflix or even like YouTube's algorithms or Amazon's algorithm, which recommends new shows for you based on your past viewing profile. So this is also deep learning running behind it. So you would have also seen this in your Amazon purchase spree or Flipkart, something where you purchase something and that says, hey, are you also interested in this? So all these are deep learning. And again, spam filters in your email, and DeepL is one of the language translator applications. So probably if you're not aware of DeepL, so Google Translate would be another example. So all these are machine learning or deep learning. Okay, so who can actually develop deep learning models? So that is a big question. So now I have shown you that deep learning does this and that for your life, and like, you know, I have said we use all these. So who can really develop it? So pretty much all of you. So there is a caveat on this. So you still have to learn a few things, but other than that, pretty much everybody can develop deep learning models. So as I already said, the community is very open to beginners. So they are willing to help beginners in this. So we are all looking for more active participants in the field. I think I had a message which says sound is not available. Can you guys hear
I'm
me?
able to hear. Yeah, I'm able to hear you, Adi.
How about the other guys? Can you also hear us?
Yeah, you can.
Okay, it's nice to know. Because okay, Sati, can you just look at the chat, because there's a person who's complaining that he's not having sound outputs.
Yeah, I have already messaged him privately, but
Okay, yeah, fine. Okay, yeah, thank you. So, and I now said that you all can develop deep learning models or all these. So how do you develop them? So it's not like you just decide in one night and then wake up fine morning and then you get all these sitting in front of you, right? So these are places where you can access something. So Keras probably is, I would say it's a beginner level Python library. So you have to know Python for this to an extent, but it's not difficult, trust me there. So Keras would be your first step into that. So this is very, very simple. So write 10 lines of code and you already have a very powerful model. And you don't want to write codes, also there is a GitHub where you can go look at other people's code, just pull them or at least download them and then use it directly. You don't even need to write your own codes. And all these models which I'm talking are very, very data driven. So the more data you have, the better they're going to perform. Again, with the caveat, so I'll explain that later. But where do you get free data sets? Because data set is a very expensive thing to build and develop. But Kaggle is actually a very nice site where you can get data sets for free. There are multiple open source data sets listed there. And again, Kaggle is not just alone for data sets. So you can actually, there are multiple competitions and things listed there. So you can go participate in them. So you have a leaderboard which says how well someone performed. And Kaggle is actually a very, very vibrant community there by itself. So it has a lot of challenges. You can participate there. And Kaggle is really going to be good for your resume. So you have participated and you probably might not start with number one place already, but even if you finish in the top 100 or 500, you're already good enough. You can gauge your skill against like the whole world or the whole matured community over there. And you want to know how to get all the techniques of, so GitHub is where you get the code, and archive is one place where you can access all the publications for free. So usually, like if you go into Elsevier's publication or some other publishing houses papers, they usually charge you money for that, and they are a bit expensive most times, papers, so say $30 or something at a time, but archive gives you them for free. So I have listed all the links here. Maybe I'll also share the presentation in the end so you can use them in the end. And so these are all things which you need for developing the model. So improves the model, gives you knowledge, gives you data set and everything. But one important big thing is the compute power. So probably you're not sitting at home with multiple GPUs running, in your machines. But Google Colab is one place where you can actually go and use their own service, Google service, for doing your compute power. So this is also free. to an extent. So it doesn't, if you're a beginner, it's quite useful, and you can also go test things out there. So it's a nice platform. You can also try it out to meet your computation needs. Again, so now coming to the recent developments part of my talk. So just remember this, just hold this picture in your mind. So we'll talk about what this picture is in the end. So as I would not be talking on every specific research out there, but just some things which interest me. So image generation and manipulation has been one key part of deep learning. So some examples of this would be, so generation of images. So this is a very, very nice site. So again, deep learning is not just all work, and it's also fun. You can look at, there are a lot of joyous things going on there. Wait a minute. I think I didn't open this one. So can you see my screen? This photograph of this nice lady over here. Hello.
Yes, sorry.
So yeah, so these are all computer generated images. So this person does not exist in real life. So as the as the website claims, this person doesn't exist in real life. So this person was just modeled by computers. Every face which you are going to see here is all computer generated. None of these guys exist in real life. So these are all developed using a technique called or a model field called generative adversarial network. So I would not be talking in detail, but if you want, we can talk about them in the end of the talk or during the question answer sessions. And one more interesting thing which has come up recently, or in the last 2 years at least, is this thing called deepfake. So there was this time where you could, so I would share my screen. I'm not sure. I would just take my screen off share for a minute and share it back. Just give me 1 minute. Okay, so this is.
It got me thinking about my full-time employees and their ability to survive on $8 an hour in New York City. And foremost in all of our minds has been the loss and the grief felt by the people of Orlando. Most of us don't get our health care through the marketplace. We get it through our job or through Medicare or Medicaid. And what you should know is that thanks to the Affordable Care Act, your coverage is better today than it was before. Women can get free checkups, and you can't get charged more just for being a woman. To give his employees came together to pass a common bill that would boost America's very, very hard times.
Some progress, at least within the small confines of the legal community. I think it's real important.
Here we go. President Barack Obama, when you giving a speech, make sure you use a lot of pauses.
So if you really look at this is the guy in the red t-shirt is the one who's actually doing the talk, and they're just mimicking Obama to make him talk like that.
A speech, make sure you use a lot of pauses.
America's businesses have created 14.5 million new jobs over 75 straight months.
We're developing technology. Every technology can...
This is one more interesting field now. If you have enough data, you can make faces of anybody say anything. So if you want, you can make Trump say things which he doesn't say usually, or you can make Obama say things which he doesn't usually. Or if you have, like, say 100 photographs of your friends, you can make them say whatever you want through a video. So that is one thing, but this also makes things scary, right? So now if you assume that, oh my God, I can make anybody say anything with just say 100 photographs, this is a scary reality to live in. So you would have difficulty trusting the media. If you look at the news bulletin of some leader saying something, you would not trust them because this could be a fake video. So the community is also vibrant in that. So it's not alone making fake videos. There is also a fake video detector. So there is this race against within the community. So if you look here, there is this phase of President Putin of Russia, where the model really shows where they have altered the original image, and where there was this deep learning magic going on. So if you look at this one here, it shows you like where the face was morphed. So again, if you really think about it, all these techniques have, faking photos or things have existed for long. It's not something like, brand new, like your Photoshop could do it. But the only thing is these models, you can do it in a few minutes instead of waiting for like an expert to do it in Photoshop for like a few days altogether. So this is where deep learning shows its shine there, And if again, going back to the image I showed you in the first, so this is the image which we started with for this slide. And this is one interesting paper by Adobe, so the creators of Photoshop. And they built a model which shows you where Photoshop has been applied. So if you look at this lady's picture, and if you look at all these zones, it is red in color and it shows Photoshop has been applied all these places. So if you don't trust a photograph on the internet, if it is for good enough quality, you can download it and use this model to see if it's photoshopped. So all these are like interesting developments where one person is trying to create better fakes and the other person is trying to find out if it's a fake or not. And these are all interesting arms race going on in the AI field right now. So again, you have all the links for it. I would share this slide so you can access everything on your free time. So there are a lot of, I'll also share other links which you can reach out in the end. And next important field, which is really strong now, is natural language processing. So I am also working for natural language processing. And there's also this front end. So what front end is? So natural language processing is when the machines understand what the person is saying. So you can just go to some movie review website and say, hey, this movie was not bad. But if the machine just looks for singular words, and if it says bad as a word there, it would probably think, okay, the review was negative. But not bad is, as a phrase, doesn't mean negative. It just says it's not very positive, somewhat positive. So all these definitions, machines would not understand if it just starts looking at single words. But now you have models which can look through process words, and then you can do sentiment analysis or things like that. And again, your translator models, your Google Translate and everything is actually natural language processing. So these are end-to-end models which process languages. And also this is very popular now and very easy to do, because now there is this concept of pre-trained models available by the community. So someone does the heavy lifting for you. So Google by itself, crawls through the web and looks at 1 billion sentences and then trains a huge model, a neural network model, and publishes that model for free online. So you can take this model and then maybe use 10,000 sentences and fine tune it to your requirements. And then you already have a model running for you for your needs. So this is one reason why machine learning is building now. So this concept of pre-training and fine-tuning by just the end user. And for the front-end part, so another thing is the ASR, the automatic speech recognition. So this you would have seen when you're talking with your Siri or your Google Assistant. So you say something, it transcribes it into words. So speech is difficult to transcribe. So many of you have different accents, different ways of speaking. So all these it should still catch and translate, transcribe it to appropriate words. So this is one huge thing which is still going on. And again, text to speech. So this is when you have a text and then it comes out as a speech. Again, text to speech is a very, very old field of research. So I think it has been done from the 1920s. But now it's just that your machine learning models can do it much, much faster. So if you go look into the internet, there is a thing called vocoder, which was in 1920. So this was like a typewriting machine where a lady was sitting and typing things, and then it would make a very human-like noise. But that just takes expertise and it's trained personnel to do it. But here, anybody can do it. And there, I also showed you earlier a video of how a video is faked, or how someone very popular. You probably have 100 hours of Obama speaking in some YouTube links and things. But this is one interesting page where Google could actually listen to your voice for 5 seconds and actually make you say some things. So I'll just play a few things for you.
The Norsemen considered the rainbow as a bridge over which the gods passed from Earth to their home in the sky.
If you look at the field called reference, so this is what is the actual speech by the person, and they use this voice part, and then here is.
His motives were more pragmatic and political.
This was not spoken by the person. So this was somebody typed the sentence into the computer, and the computer model generated how the person's voice would look like. So just going for a different example.
They left him then, for the jailer arrived to unlock the door and escort them to the office.
So this was the original voice.
This work reflects a quest for lost identity, a recuperation of an unknown past.
Purely computer generated. So how they do it, just a quick thing is, so they use spectrograms, so they have this Mel frequency, spectral coefficients, and all the other things. So there are a lot of things behind it. So it's not very straightforward. And again, all the results published here are probably the very good results. So there might be failures there, which we, as in, when I'm working every day in my office, I see that sometimes it fails, but most times it does work well. And the thing is, all this, models were trained in English data sets. So this was like, the training there was probably listening to some guys read out something in English, and also like a different set of sentences and training the model on that. The interesting part here is that there is also possibility to transfer your, speech across languages. So they recorded somebody saying something in Chinese.
轻轻敲醒沉睡的心灵，慢慢张开你的眼睛。
And they actually made the use the same voice to say this sentence in English.
A long time ago, the 2nd December, a cup
so
of
here
water.
You would see that it's not perfect yet. You would see this machinish voice. But if you listen to this.
人恒过，然后能改，困于心，恒于虑而后作，征于色，发于声，而后喻。
A long time ago, the 2nd December,
so
a
this
cup
is
of water.
Marginally better if you listen, but it still sounds machinish. But it's a bit better because here the person was speaking and it is changing into speech. Here the person was singing, and the way your vocal cords respond are a bit different when you're singing. The folds are different. Your spectrogram is going to be a bit different. So this is not a perfect method, but hey, it gets you across to a point of usability. So this is another huge research going on. So people are looking for a lot of NLP engineers out there. So this is going to be there in pretty much every device which you're going to use now. So we are, at least as a company, we are doing it for, the industry use. So when you're working in a heavy industry, you can talk to the machines instead of, going and, changing it with buttons. Or when you're riding some forklift or anything, you can just say, do this, do that, instead of, pressing buttons or doing difficult things. So this is going to be a huge field. Then there is a lot of research going on. So I would be happy if you are interested and take part in it. And the next would be, so we have seen cases where people are trying to fake things and people trying to fight with things. So there is a question of morality coming into, machine learning field. So this again is one simple scenario. This was for the field of autonomous driving, which has been at least in talks from say 2012 now. So here assume this is an automatic car. So this is an autonomous driving car, and there are few people crossing the street, and the car can now do two things. So it can go straight, run over the people where they would all die, of course. Or the car could then decide, no, I don't want to kill people, so I'm going to just take a hard turn, and then I'm going to go crash on this roadblock. So the scenario is like, if it runs over the people, they are going to, definitely die. But if it goes and crashes on the roadblock, there is a 35% chance of, your car crashing and people dying inside, because, your car has airbags and all the safety features, because, you're all wearing your seatbelts. So I would like to have one more quick poll where assume you're in the car, go to menti.com again and use this code where assume you're in the car. So you being in the car, what would you want the car to do? So would you want it to go straight to save your lives? You don't bother about the people crossing, Or would you want to just, your car to take a hard turn and then, save the people, but now you're putting your own life and your co-passenger's life in the risk. So how do you guys decide on this? So let's just take 45 seconds to do this. Guys, you can answer this. Very subjective. Your answers are not going to be recorded or sent to, the real developers. Okay, maybe 2 more seconds. Okay, so fine, let's go to the next one. Okay, now the predominant thing was now at least the owners thought that the car should go crash on the roadblock and save the pedestrians, but probably their goodwill, they don't want to cause harm to others. But now assume you're the pedestrian, what would you want the car to do? Would you want the car to run over you so that maybe you die, but the people in the car are very safe? But the other case is like you want to stay safe, but you don't care about what happens in the car. So maybe 10 more seconds and we close this poll too. Okay. So again, the predominant choice of the people, at least in the ones voted, was that the car should take a turn. So it doesn't matter if you're on the street or in the car. So you all think it's better for the car to, go crash on the roadblock rather than kill people for sure. So here there is a chance of survival. Probably that's your line of thinking. So, but this is a question of morality if you really come to the development of things. So again, so it is nice to try to save people in a better chance, but would you give the control to a machine to decide who lives and who doesn't live anymore? So think of it. There was this scenario in Italy now. So again, the COVID case. So where there were not enough, hospital beds there. So the doctors really came to a, situation where they had to decide whom to save and whom not to save. So if 3 people come, there is just 1 bed. They pick the person with a higher chance of, survivability than the other. So they consciously let the other people die. So it's not a mistake. It's the, the situation which they were put into. But here they could, answer you why they did all that. So the idea is like, who takes the responsibility for the deaths? So here in the COVID situation, a doctor would be like, I did this because of so and so and so reasons. But here a machine would not tell you it killed them for this reason or it didn't kill them for that reason. So this is a very big, question of morality in machines. It's a very big thing now. So this is an active research. This poll, this is a very simple version of it. There is a huge version of the poll in the web by Massachusetts Institute of Technology. You can go there and you can feel free to take part in this poll. So you have like 20 questions and you can keep taking it and see how the world thinks and how you think compared to the world. So again, coming to it, so the machine cannot tell you why it did that now. So this is one of the biggest research topics now. So explainable AI. So right now your machine learning models are like magic boxes or black boxes where you throw in data, huge amount of data to train it, and then in the deployment phase you throw like data and it just spits out some answers for you. So you don't know if it's correct, you don't know if it's good enough or anything. So this is fun for like all the face images I showed you. It's fun because nobody is going to get harmed. But if it is like an autonomous driving situation, you might have seen the Tesla case a few months ago, where it went and crashed in a tractor or a truck, or it ran over some person in the dark. So you cannot be okay, I don't care what the machine does as long as it works. So this is one big thing now. So it should not be a black box model. So you should know why it came to a specific conclusion. So you should know the mathematical backing behind the model decision. Now the models are all working on non-linear operators. So it is very difficult for us as humans to understand why it does some things. But this is one of the biggest things going on now. So there are also multiple other reasons for doing this. It's not alone like knowing what the model does for morality's sake, but it also gives you an option. If you know what the model does and why it does that, you can actually go design more efficient models. And why would you need efficient models? Because now it takes a lot of compute power. Though the compute power is cheap, you can only still implement it in like huge machines with GPUs and things. So you can, if all these explainable AI works very well, you know how the model works in like perfect detail, you can implement it like in your mobile phones, or say a Raspberry Pi, or like an IoT device in the end. So this is something which is quite big now. So this probably is bigger in the next few years too. So if you really want to get into machine learning research, this would be one big place for you guys to step into. And the other thing is research in medicine. So again, this has a lot of moral implications. So as I said, the corona doctor situation in Italy, the doctor can say it, but the machine cannot. So again, so this involves major moral and ethical dilemma. But saying that, machine learning has improved a lot of lives. We can see this obviously. So there are evidences of this. So there are places where machine learning methods already outperform the doctors. So there is this hospital in the United Kingdom where they actually went and built for ophthalmologists, so these eye doctor guys. So they went and built this huge machine which would help them realize eye patients or classify what their problems was. And at times these models are doing better than even the best doctors. So they still don't trust it 100%, but this would be a big step. And there are a lot of other things. So also, again, coming back to the COVID situation, because all know what's happening here. There are models out there which showed you if the person had COVID or not, looking at the X-rays and things. So it's not like a magic test which solves everything, but yeah, looking at the X-rays and things, they could actually listen to this, look at this X-rays with the models, and yeah, they had around 95% accuracy on predicting if the person had corona or not. And again, there was this diagnosis which you can do, and there's also not only say like the detection part. So there was also this hospital in Hungary which helped organize patients. So it was patient management, when they could come in and how the pre-training cases were followed up. And this was like this changed it by around 50 days. So earlier it took 50 days. Now with the machine and support, it only takes about 21 days to do it. So 33 days when you're a patient suffering from cancer is a huge thing. So there were many lives saved by this. There were multiple studies on it. So all these are something which are very good. And again, automated data labeling. So you take some patients' records, probably it's in a different language, you go to a different country or something, and then you feed all your medical records into the machine, and then it translates it, or it picks up important parts and puts it into your database. Sorry. Oh, someone is having fun with the slides there, drawing pictures there. So coming to the other interesting fields, these are the fields which I showed you examples and things. So there are more interesting fields. So computer vision, which probably all of you know is one of the biggest fields out there, and it has seen a lot of success stories already there. So autonomous driving is one big example. Google is doing it, Tesla is doing it, most major companies are doing it. So, and then there is this ADAS, so there is data compression, which you can use, simulation and artistic renderings, so deep learning. So all these I'll give you. So these are places where you can go learn it. So it's not all like, these are all amazing techniques, so but I don't tell you where you learn them. So these are all places where you can learn them. These repositories are very, very good. You can actually go and use these for improving your techniques. And the biggest thing is get your hands dirty. Work on it, build your model, support the community, and use it. This is the best way to learn it. Okay, someone is having a moment. Okay. So the biggest takeaway from me is like deep learning is a very big field. So there are a lot of things which you can do with it, and there are a lot of fields which deep learning has not penetrated into. And so these are good places for you guys to start with. So, and there are a lot of resources out there. You can use them all. But things to remember, deep learning is not a magic solution to everything. There are cases where deep learning was shown to have caused discrimination. So it preferred male employees because, let's say there is a job application, it went and preferred male employees because it only saw male employees as, example data. Or there are multiple examples. So it could not detect people of African or American origin when they were doing all this face unlock or things. So these are all real problems in the real life. So all these also exist. So understand the algorithms you develop as an engineer has real life implications. So be responsible with your creation. So because you can do a lot of bad things with it, and also each person's data belongs to them. So respect the loss of their privacy. So this would be the major completion of my talk. And just to give a quick lead on what Satya would be talking on. So as I said, machine learning still has a lot of fields which exist to enter. One of them is definitely oil and gas. I believe it so, because oil and gas is a very large industry with different people involved there. It's one of the very expensive fields because it takes a lot of money and time to build it. And then the problem with oil and gas is it's well known to keep sticking to old techniques. So they are still using technique from the 70s because that's what is proven. Nobody wants to change because there is no track record of something good happening. And there is also good reason behind it. So even if one valve breaks away and causes some problem because of your faulty machine, your whole plant is going to blow up. So this is also there, but there are still some minor fields where machine learning is used, and Satya would talk about it now. Satya, you can actually take over the screen if you want, or I can also switch screens if you want. Hello.
I will take over the screen, Adi.
Okay, I'll stop the share and then you can take over.
Okay.
Satyanarayana, please take over the session.
Yes.
Okay, please. Thank you.
So basically, now we are going into the predictive maintenance in the oil and gas. So as Adi told, in the oil and gas industry, we don't use much of machine learning or even the latest technology. Why? The reason, Adi also told the reason. Because the industry, they set their standards, like they always want the proven technologies. They don't want to change something. If it is working fine, they don't want to change it because it involves a lot of cost. Now we are not talking about lakhs or something like that. We are talking about thousands of crores. If a plant gets shut off even for a day, we are talking about at least a 2 crore or a 3 crore loss. So that is why we are now going into what I'm going to say about is vibration monitoring. This is a very, very old technique in machine learning concept, but still this is one of the major techniques which is used in oil and gas. So what we are vibration monitoring. First, I will let you know what the vibration is. Vibration is nothing but the oscillatory back and forth motion of a machine from its normal position of rest. Now, like a pendulum, like the pendulum going back and forth, it creates a very, very minor vibration. So if you think of a vibration, all the rotating equipment, such as in the oil and gas industry, such as pump or compressor or turbines, they all produce some minor vibration. Now, what happens is when the machine starts deteriorating over a period of time, when the machine is new, the vibration will be very, very less. But over a period of time, when the machine gets old, the vibration gets increased. So by monitoring this vibration, we can obtain the information how the machine condition is. Like, let me say the vibration has increased over of time. We can say that the machine may fault over in the next 2 years or something like that. So it is time to replace that particular equipment. So why the importance of vibration monitoring system is, each point is protection against a machinery fault. So when there is a fault, when there is a misalignment, or when there is an imbalance, or when there is a bearing failure. So for these things, it is important to monitor the vibration. And the other things which we should actually keep in mind is the temperature of the particular pump shall be maintained at a particular range, because if it crosses, then probably it becomes a hazardous condition and we may have to trip the pump. And then the speed. In addition to the vibration, we have also looked into the speed. We always have an overspeed indication in all the turbines, in all the motors, so that it does not cross a particular speed limit. If it crosses a particular speed limit, the machine may go out of control, and it may produce a hazard or even a blast in worst case. And this is an example of just a sample of a vibration monitoring system. Now what we are having is, we are having a probe in the shaft, and from the probe we are having an extension cable to a junction box. So basically we may have many number of probes, not just a single probe. We may have many number of probes, and all these probes shall be connected to a single junction box. And from the junction box, we may take a single multi-pair cable, and it will go to a barrier. And why we are having a barrier here is, if the particular equipment is present in a very safe area, we have to limit the current going to the safe area. So we are having barrier to limit the current, and then we are having a processing unit. Now this host computer is nothing but a server one, which is maybe a Bentley Nevada server one system, which monitors the vibration recorded from the probe, and it will suggest whether this particular instrument will survive for the next 2 or 3 years, or we have to change it. These things we will receive from the computer. My topic, I will not go much into the technicality. I will just let you a common overview on how the vibration monitoring is done in oil and gas. Now, in this slide, you are seeing the various probe positions where you can place the sensors. So what are the types of sensors we can use? You can see it. We have the position sensors. So the position sensors is nothing but the alignment of the shaft shall be proper. So that is why we are having the axial position sensor. Then we have a radial shaft vibration sensors, which are able to measure the vibration produced by the shaft. And then we are having overspeed detection centers at S7, S8, and S9, which measures the speed of the gear. If the speed of the gear goes over a particular point of time, then we have to trip this particular equipment. And then we have phase reference. Phase reference is nothing but it checks the misalignment. So this is a picture of a BN rack. So if you see, even for all the system, even if it is a vibration monitoring system, it is a predictive maintenance. We need to have certain things like a power supply. We should have a redundant power supply and everything. So as I told earlier, this is a system one BN rack. So from here, we will give a Modbus cable from here to the server system one. So the vibration characteristics, how we are able to measure the vibration, the three main things are the frequency, amplitude, and the phase angle. Now the frequency gives the information what is actually vibrating. The amplitude, it gives the severity of the vibration, how much the vibration actually affects. Now the phase angle gives the information what is the reason the vibration is happening on. So as I told earlier, this is the amplitude versus frequency, and I have just mentioned this just to explain, just to let you have a common view of what is amplitude and what is frequency. Amplitude is nothing but how much severity the vibration is. So if the amplitude is high, then the severity is very much high. So which means the equipment is actually in a very bad shape. Now the frequency indicates the source of the problem, and it also indicates the time period of which the problem occurs. So as you already know, frequency is nothing but it is the inverse of your time period. So if the frequency is very much high, then the problem is occurring at a very small interval of time. It is occurring very frequently. So for a instrument which is working good, we need to have amplitude shall be as much as less as possible, and even the frequency shall be as less as possible. So what happens is, as I told earlier, we have a server one, which is a Bentley Nevada system. So it actually, we have actually modified the server one in such an extent that it checks the machinery vibration with predefined machine learning values, and it gives an output whether this particular equipment needs to be replaced or it has a very severe problem. All these things are obtained from the harmonic functions of the amplitude and the frequency. This we are calling it as a machinery signature. Now, as I told earlier, the probe sensors which we are selecting, we cannot select a probe sensor of whatever reason we want to. We have to check whether we have to take into the following factors while selecting a probe sensor, such as the sensitivity. The transducer must be sensitive enough to produce a detectable output. So we should have a transducer which actually produces a more number of output even for a minor change. And then the operating range of the transducer has to be within the limited range. And the accuracy, these things, when you have studied in college, you always overlook the advantages or the disadvantages of an instrument. But however, when you work for the instrumentation company, it is not necessary to have so much of knowledge about the construction or working of an instrument. The principle of an instrument, yes, you have to know. But the main thing is you have to know where you can use that particular instrument and what are all the advantages and disadvantages of an instrument. So these things, when we are studying in college, we don't give much importance for these things when we are studying in college. So we usually, we normally make a reason like, always we like advantages as less cost, less maintenance cost. Those things we should not look into like that. We should have a proper idea where an orifice shall be used and where a venturi tube can be used. So when you are selecting a transducer, we have to take into the accuracy, you have to take into the response time. The response time is nothing but when there is a change, when there is a small change in the input, and how much time it takes for it to reflect on the output. So this is the response time and the environmental capability. So the transducer which we are using, it shall be selected based on the environmental condition. For example, if the transducer is cannot be used on a hazardous area, so then we cannot use that particular transducer. We have to look all these things. And then the insensitivity to unwanted signals. This insensitivity to unwanted signals can be removed even using software. But in general, it is better to have a transducer which does not produce much of noise. And also, as you already, as everyone knows, cost plays also a major role. So the cost of a transducer, when there is a particular comparison between two transducers which have the same output, then our important consideration will be which transducer is of less cost. And the other thing which where we are using machine learning in the oil and gas industry is drilling, but this is still very much a work in progress. This is nothing but we are having a various geologic models which will give an idea about how this information is obtained from various geological models obtained from the earlier refineries, earlier drilling areas. So from these areas, a model has been developed, and this information allows us now allows us to where the oil and gas resource future is available. So now that's all about machine learning. So now I will go into the oil and gas industry. Mainly, I will be talking about the EPC industry. So unlike the machine learning concept, when you come into the oil and gas industry, it is not going to be much of about latest technology we are going to use. It is mainly, we'll be using a technology which is very much old, but it will be very much trusted technology. So when a client, when an operator is going to set up a plant, he's not going to ask you how much latest technology you are going to use it, because he wants an average runtime of a plant would be around 20 to 25 years. So he wants a plant to run without any problem for 20 to 25 years. So he will not going to ask you which is the latest technology where we can use here. He will ask, show me a technology which has run for 20 years before so that I can use it. That is why in oil and gas industry, we will be usually using a technology which is very old, but it will be very much trusted, because the money involved in oil and gas industry is such high. So the client, he will not want to take any chance. Now, talking about the EPC industry, I'm not sure many of you know what is an EPC. EPC is nothing but engineering, procurement, and construction industry. So this is nothing but if a particular person wants to set up a plant, set up a refinery, he cannot set up a refinery by himself. He will ask the experts who have set up previous refineries to set up a refinery for him. And he will have a particular demand. He will want to produce a particular set of output. Like he wants to produce a particular tons of urea or tons of petrol per day. He will put his demands, and this EPC company, they will work on it. They will design the plant, and then they will procure the instrument. Procurement is nothing but purchasing the instrument, purchasing the instruments or equipments or whatever it is, and then constructing and commissioning the particular process plant, and then hand over it to the client. So this is the EPC industry. So in the EPC industry, we have, I have listed down the departments here. In addition to the departments, I have listed down it here. We also have the non-technical departments, and non-technical departments, which may include like the estimation, like if a client comes up with a plan of having a refinery, and we have to set up an estimation cost, how much cost is required to set up that particular plant. And you have to set a profit margin for yourself when you are building a plant, and then sell it off to the client. So this is the estimation department. And then you have a procurement department. The main job of procurement or purchasing department is to purchase the equipment or the instruments or whatever items we require. So this we are purchasing it from the other vendors. So these are the two main non-technical departments involved in the EPC. The technical departments involved in EPC are the process department, the piping department, mechanical and thermal department, or we can call it as static equipment department, and machinery and packages department, which we can say it as rotating equipment department. Then we have civil and structures department, and we have instrumentation, control, and telecom department, and finally we have electrical department. So in an EPC industry, almost all the core engineering groups would have a job to do. So it is nothing, it is not a industry where like an IT where a particular set of group only will be involved. Here we will be working with all the core engineering departments, and we need to have a proper interaction between each department. So you need to have a basic understanding of or working nature of each department. So first we will see about the piping department, because piping department, the main people who not the main people, the only people who would be involved in piping department would be the mechanical engineering students. So what does piping department mean? Piping department is nothing, it has three different sections. I will first tell into the three different categories. They are into piping design, piping stress, and piping materials. Now, first I will move on to the piping design. Piping design is nothing but whenever you see a refinery plant, you will see a large number of pipes going from one area to another. Now you have to route the pipes such that there will be no clash to an equipment or no clash to an instrumentation junction box or a cable or anything. So the main job of the piping design subdivision, piping design department is to route the pipe in the process plant so that there is no clash, and they have to select the flanges. Now, if you want to know what is a flange, the flange is nothing but it is used to isolate an instrument from a pipe. And second is the piping stress. So when you are designing a pipe, you have to take into issue of how much pressure and how much temperature that particular pipe can handle. And based on that, you will actually design the pipe thickness. So the piping stress department main job is to determine the thickness of the pipe. In EPC industry, we don't mention it as a thickness, we call it as a schedule. Their job is to check whether the schedule of the pipe is able to withstand the pressure and the temperature. Now, this is a very, very important process because you may think it is just a small calculation, but imagine what happens if a stress calculation goes wrong. A pipe may burst. If in our oil and gas industry, most of our fluids which are going are hazardous fluid. They may be toxic, they may be corrosive, or they may be flammable gas or flammable liquids. So even a leak can turn into a very big problem. So the piping stress department main job is to prevent any leaks. You have to maintain the stress so that there is not any burst happening. And the final thing is the piping material department. Piping material department is used to select the material of the pipe based on the process fluid, temperature, and pressure requirement. Now, as I told earlier, the process fluid may be corrosive in nature. If it is a corrosive fluid, then the selection of material becomes very much important. Like we cannot use a normal carbon steel for a corrosive service. So for a corrosive service, we may go for a nickel alloy such as cast alloy or mono. So, and you may wonder why we cannot go for a cast alloy for all the pipes, because it is very much cost. It is a very high cost when compared to a normal carbon steel pipe. So the piping materials, they have to check for which particular areas they require these corrosive resistant materials, or the temperature and pressure requirement is high. They may even sometimes they go for a higher grade material. Next, we will go into the process department. Process department is nothing but people who have studied chemical engineering. They come into the process department. And here also we have categories involved in process department. First thing would be the process design. Now, the chemical department, they have the knowledge of how the process shall be defined, like how a particular urea plant has to be made, in which particular technology we must use. It all confirmed by the process design department. Now, in addition to the process design department present in the EPC industry, we have a specialist process design department, which is nothing but licensor. So this process design department, they actually develop the actual process of the process plant, and they actually give the input to develop the PI and IDs, which is nothing but the second division of the process department. They develop the PIDs based on the process design inputs, and then based on the instrumentation inputs and the mechanical and thermal inputs, package and machinery comments. Next, we have the process safety department. So process safety department is nothing but when you design a process plant, you have to look into the fire and gas hazards, and you have to place the fire detectors, flame detectors at particular area, and the sounders and beacons to give information to the operators or the people who are working in the field that something hazard has happened. So for this, you have to first determine where the exact smoke detector or heat detector or the sounders and beacon has to be present in the field. So the job of the process safety department is to develop the layouts to ensure the position of these fire and gas instruments. So here is the example of a piping and instrument diagram. So this is how you actually have a P&ID. So here you have the instruments. Here you have a flow transmitter. If you are able to see, I am not able to zoom further. This is the symbol of a pump. And here you have a closed loop flow transmitter with a flow controller and a flow wall. So this is just a small example of a BNID. And here I have mentioned a fire and gas layout. This is developed by the process safety department. You have a gas detector placed at this particular area. This is nothing but a gas detector methane GDM. And this particular selection is based on considering which is actually accessible to the field persons who are working in that particular area. Now, if you place a detector somewhere here where the employee where it cannot be accessed by the employee, then it becomes an issue. So the safety department has to ensure that the gas detector is accessible to the field persons. Next up would be the civil and structural department.
Satya, could I interrupt you for a minute?
Yes, Adi.
ஸ்க்ரீன் ஷேர் மட்டும் ஆஃப் பண்ணிட்டு மறுபடியும் அன்னோட்டேஷன் ஆஃப் பண்ணி ஆன் ஸ்டார்ட் பண்ணேன். ஏன்னா ஸ்க்ரீன்ல ஏதோ வந்துட்டே இருக்கு.
ஓகே.
ஷேர் பண்ணும்போது ஆப்ஷன்ஸ்ல வந்து அன்னோட்டேஷன் ஸ்டாப் பண்ணிட்டு ஆன் பண்ணு.
ஓகே. Okay, now it is fine.
ஓகே, இப்போ ஷேர் பண்ணிக்கோ. ஒன் மோர் திங், இன்னொரு 10-ish மினிட்ஸ்ல முடிக்க பார்க்குறியா? 15-ish மினிட்ஸ்ல ஒரு 10 மினிட்ஸ் கொஸ்டின் அண்ட் ஆன்சர் வச்சுக்கலாம்.
ஓகே
ஓகேடா, ஓகேடா, ஓகே, தேங்க்யூ.
So for the civil and structural department, the main thing is to check the to develop. For the civil and structural department, the main thing would be to make the foundation studies, whether the foundation can withstand that particular pressure, particular load. And the next thing shall be whether the particular structure is at a risk of collapse. They have to do the foundation study first. They have to do the soil study to determine this particular soil can withstand this much of ton. Usually in the oil and gas industry, the structures we are talking about, they are literally tons and tons of structures. So the role of civil and structural department is to ensure that structure does not collapse. And they develop the computer aided design technology for the simulations. They develop the models, they check everything. And from these models, we take an extract, we take a 2D extract, and then we give it to the building contractor. He develops the structures. And I will briefly go into the mechanical and thermal, which is nothing but static equipment. Static equipment is nothing but heat exchangers, vessels, drums, and tanks. So these particular static equipments, they don't produce any vibration when they are working. So for these equipments, the main job of this department is to prepare the data sheets of these equipments, and then they have to give it to the vendor. And then all the vendors will come up with their own solutions, and you have to technically evaluate which particular vendor satisfies your job specification. And then you have to review the vendor drawings and the documentation so that it can be sent to site for the implementation. And for next, we are going into the rotating equipment. Rotating equipment is where this department is actually where the cost is hugely involved, because this is where the compressor, turbine, engines, and pumps are involved. All these are of high cost materials, and these equipments also take a lot of time to manufacture. So whenever a project starts, you first order a compressor or turbine or engine, because since manufacturing of this takes a lot of time, you have to start this job at a very early. So this is nothing but the same thing what we have seen. And one more thing which I want to mention is the package department. The package department is nothing but sometimes this particular compressor shall have the same vendor itself will give the control system associated with it, and he may also give the instruments and everything associated with it. So when everything is given by one particular vendor itself, then we call it as a package. So this package, so the example of this package is a compressor package with an anti-surge valve using an ITCC system. ITCC is nothing but a turbine control system, and anti-surge valve is a very much important valve because this is only used to trip the compressor. Next up, we have electrical department. So the main job of electrical department is to provide the power supply for the entire plant. They have to check the load calculation of all the motors involved in the plant, load calculation of the compressor, and they have to develop the transformer based on the load calculations. And they have to design the MCC. MCC is nothing but the motor control circuit, which gives the power supply for the motor, which also gives the start command or stop command for the motors. And then they have to prepare the single line diagrams for the load distribution from the transformer to the each motor and compressor. Then we have the lighting calculation. Lighting calculation is nothing but usually the process plant runs 24/7. So you will have lights all over the process plant, and even in the control room. You have to calculate how much lighting you require, how much lumina candescence you require. And the trench sizing calculation is nothing but all the electrical cables and the instrument cables, they have to go, they either go through a tray or they go through a trench. Trench is nothing but it is an underground, you lay the cable underground, that is called a trench. And here you develop the 3D modeling of the power cable through the tray or trenches. Okay, next I will, here I have prepared more for the instrumentation department. So I'm seeing Bharati has raised hand.
If you have any questions, just type it out in the chat, Bharati. I think you raised your hands, maybe you can just type it out there.
So just for the instrumentation department, you have three main segments. You have a client or operator segment, and EPC or PMC segment, and then you have instrumentation vendor companies. I'll just go fast because I don't have any time. So client or operator is nothing but he is the one who is running the day-to-day operations of the plant. He may have a refinery, petrochemical, or an LNG complex. So when you are working for a client, you may work in a very, very remote area. So for an instrumentation, for an instrumentation person who is working in a client, your job may be of an instrumentation engineer, or you may be you may work as a control system engineer or operator. So role of instrumentation engineer in a client side is you have to be day-to-day operations of the plant is based on your understanding. So you have to check whether you have the sufficient spare available, because when an instrument is at fault, you have to replace it immediately. So you have whenever you prepare a project itself, you have a particular amount of spares available. So you have to check the day-to-day spares, and you have to prepare the data sheets if you want to purchase it further. And if you have a small any instrumentation or control system issues in the plant, if you have a instrumentation troubleshooting error, you have to do it by yourself. And for the control system engineer, the main work should be if there is a failure in the IO card or in the FTA, field terminal assembly, you would have to replace it. And you would be able to interface your main control system with a third-party control system. As I mentioned earlier, sometimes the packages, they have their own control system. So their control the package control system being interfaced with the main control system, you use either OPC, object-oriented process control, or you use a Modbus interface. So you should be able to interface these things, and you should have a proper understanding of control logics, and you should be able to do PID tuning. So the Indian clients, you may be aware of ONGC. And HURL is nothing but Hindustan Urvas Rasayan Limited. They are mainly into fertilizer job. IOCL, you guys would be aware of. And Reliance Industries is the main player in oil and gas industry. I think people who have come from north, they may be aware of Reliance Industries. Jamnagar plant is India's large, not just India's, it is Asia's largest refinery plant. RCF is nothing but they are also into fertilizer industry. RCF has the largest fertilizer plant in India. And then you also speak international client. I think everyone knows about Saudi Aramco. They are the largest company in the whole world. And then you have Dow Chemicals. And this is Shell. If you are not aware, Shell owns the largest ship in the whole world. And then you have Qatar Gas. Qatar Gas is the largest LNG manufacturing company in the world. And Novatech. Novatech emergence from the last 5 years is very much fascinating. In last 5 years, they are into number two position in the manufacturing of LNG. So already we have discussed about EPC and PMC. So in EPC and PMC, you have two types of work for an instrumentation engineer. Either you work in office-based or in site-based activities. Office-based work involves the installation design, instrument design, and the control system design. Site works involves the field engineering activities, commissioning activities, and startup activities. So the role of EPC and EPC instrument and control engineer is doing basic engineering and feed activities. This is before a project is awarded to an EPC. You do a basic engineering study, and then you submit it to client. And based on that engineering study, client will further go with the bidding of the plant. So regarding the optional services, this is nothing but the system FAT participation. FAT is nothing but the factory acceptance test, where you check whether the particular control system is ready to be sent to site for integration with the field instruments. So next up is role of instrumentation engineer in EPC. So I don't want to dwell much into it. So it is nothing but I will just say you will be preparing the instrument data sheets. You will be preparing the instrument index is nothing but this is like a overall database of all the instruments involved in the plant, and you will be mentioning what type of signal that particular instrument is giving. So this particular information is taken from the instrument index, and it also has the manufacturer and the model number of the instrument, everything. It is nothing but the database of the entire instrument. Then you have to procurement of instruments. You have to do support with the procurement department of purchasing of the instruments. Then you have to prepare the cable schedules, how much cable you require for the whole plant. And the role of control system engineer, you have to perform the technical specification of control system. What type of control system you want? Like, for example, Honeywell employs client-server architecture, whereas Yokogawa employs normal each controller-based architecture. And next up would be control system layout and wiring drawings, how the control room shall be designed. For the other, the field instrument is designed by the instrument engineer. However, the entire control system is designed by entire control room itself is designed by the control system engineer only. And then you have to review the control system vendor documents, whether what you have asked is satisfied by the control system vendor. You have to check it. And then you have the telecom. Telecom involves PAGA. PAGA is nothing but public addressable system. You have the loudspeakers. These are all the PAGA. And then you have telephone. Telephone is nothing but the telephone involved in the control room, and the access control, which particular person needs to be provided access for which particular room. For example, the control room access is given only for authorized person. Then you also have CCTV. Okay, this is nothing but an ICSS cabinet. Here you are the two main things, two big things. This is nothing but the power supply module, and here you have the first two cards are the controller, and next up you have the IO cards. So here you have 4 blank cards, and this particular is nothing but for only the first rack would be having a controller. The next rack would be having IO card from the start. So this is nothing but a serial interface card where it transfers the controller information to the next particular rack. This is an example of a Yokogawa ESD system. So the main EPC companies are TechnipFMC. This is the company where I'm working now. They are the industry leaders in the EPC. And then you have SAIPEM. SAIPEM is actually they actually formed from the ENI client itself. And most of you will not be aware of Samsung Engineering. Samsung is one of the major players in oil and gas EPC industry. They have constructed the world's largest ship. As I told earlier, Shell is the owner of the world's largest ship. That ship was constructed by Samsung Engineering and it was designed by TechnipFMC. And then you have McDermott. In India's major EPC player is L&T Hydrocarbon Engineering, or in short form we call it as LTHE. And then you have Toyo Engineering and Fluor Corporation. Fluor Corporation is not just into oil and gas; they are also into nuclear industry, and even in they also do services for NASA. And then finally, I have instrumentation vendor companies. So the instrumentation vendor companies are nothing but they are the manufacturer of instrumentation items such as control valves, transmitters, and control systems or analyzer instrument, and the 4 main measurable instruments: level instrument, pressure instruments, flow instruments, and temperature instruments. So they are actually the experts in the particular segments. Where if you talk to a person who is working in an instrumentation vendor company, they will have more knowledge about that particular segment. So the instrumentation vendor company, I think most of people who are working, who have studied instrumentation would be aware of the instrumentation vendor companies like Emerson, Yokogawa, Honeywell, Tyco, Henderson-Osser, and MSA. So of all these 6, Emerson is a conglomerate. Emerson and Honeywell, they are not just into one sort of business. They are into manufacturing of instruments. They are into manufacturing of control system. They are into analyzers and everything. Emerson and Honeywell. Yokogawa, they are only into control system and they are into transmitters. Tyco is a specialist in fire alarm system. And Henderson-Osser is an expert in level instruments specifically and radar to be more precise. MSA is nothing but a major player in fire and gas detectors. Presently, it was acquired by General Monitors. So these are just the pictures where I have worked. I worked in Yamal LNG for 1.5 years. I have worked as a field instrument engineer. So this picture was taken around the temperature of -35. So when you are working for a client, you will be placed in a very, very remote location. So this is nothing but this is actually a flare. This picture was taken during the snowstorm. So these are just instrument pictures. This is a control wall with the exposure to atmosphere. Now, when we are designing a control wall, which is going to be placed in severe atmospheric conditions like this, you have to take into consideration of the insulation. Either you have to give a tracing or you have to provide a heating box. So this is a control wall with temperature wall, and you have a control wall with hand wheel. This is a picture of a flame detector. And then you have a gas detector oxygen. GDO is nothing but gas detector oxygen. And here is a picture of a venturi tube. So it is very, very essential to know the flow of the service shall be from left to right. So if you install it in a reverse way, the entire process will collapse. This is a JB, junction box. Temperature transmitters. And here you have a pressure transmitter inside a heating box, because this particular pressure transmitter cannot work in a severe atmospheric condition. So you have placed it in a heating box. And this is a terminal block inside a cabinet. That's it.
So guys, so Satya also has come to an end of his presentation. So this is where you can reach us, guys. So you have both our LinkedIn IDs, and then if you have more questions, you can email them to us. Anyway, the organizers would already share the presentation PDF with you. So probably with your certificates or something, you'd get them. And yes, so these are contact details, and Satya, maybe you can just proceed a few more slides and we'll open it for questions for a few minutes. Thank you for your questions. Yes. So if you have any questions, you can raise your hands. I can unmute you guys, because usually I'll have to unmute you. So if you raise your hands, I would try to unmute you. Or you can also ask it in the chat. We'll try to address it maybe for a few minutes, because we are already, we are sorry that we overran the time, but yes, it's open for questions now. And I also think the organizers have posted the link where you can get the feedback form for the webinar. So any questions, anybody?
So if there are no questions, I like to have a very normal question.
Yes.
So if you have a scope, so we said that we have EPSC, other companies. So where to start after being a fresher? Whether it is going to be having an experience in joining these companies, or directly we can able to join those organizations.
So Satya, this is a question direct to you. Yes, go ahead.
Yes. To join an EPC company, usually it requires experience, but however, every year, almost all the EPC companies, they recruit from the campus. But presently what has happened is, because of the job scenario of what is going on, all the EPC companies have went to top tier colleges. Like only they are going into tier 1 colleges. And even in tier 1 colleges, they are not going into a campus sort of thing. They are only organizing the off-campus sort of thing, where only the toppers are getting invited to attend the interview. So what I would suggest is, it is not necessary to start your career directly in a major MNC EPC. You can start from a normal EPC, and then you can move up with the grade to a big EPC company. Because when you directly join a big EPC company, you may not have, you may not work in all the various tasks which I have mentioned. You may be put to one particular task, and you may become an expert only in that particular task. But when you join a small EPC company, where you may have to do all the work.
Hello. Yes. Thank you, Satyanarayana and Adhithyan. Participants, suppose any queries, you please ask, put it in the chat box. I think they have answered nicely for your so far questions. I thank you, Satyanarayana and Adhithyan, for your nice presentation. You please keep in touch whenever you come to Chennai, please visit the college. We'll be happy to receive all the, particularly alumni. We heartily welcome your friends.
Yes, sir, sure. Thank you.
Sure, sir.
Thank you, Sathyanarayan. Thank you, friends. Thank you, participants. Thank you all. Thank you, sir.
Okay,
Thank
sir,
you.
so yes, we'll close the presentation now. Yes.
Yeah, please. Sir,